Good evening, everyone. The recipient of the Phi Beta Kappa Science Award for 2010 for her highly illuminating Complexity, a guided tour, Oxford University Press 2010, is Melanie Mitchell, who is professor of computer science at Portland State University and external professor and member of the science board at the Santa Fe Institute. As President Kate mentioned, the Phi Beta Kappa Science Award was established in 1959 to encourage literate and scholarly interpretations of the sciences by scientists. Speaking as a professional non-scientist, it is difficult to imagine a more accessible and readable scholarly work on science than the one that Melanie Mitchell has produced. Professor Mitchell commences her study by acknowledging that since the time of the 17th century founders of the scientific method until the beginning of the 20th century, science has mostly pursued a reductionist agenda, and that much of what she is about to consider under the rubric of complex systems will fall outside of that agenda. She also acknowledges that in scientific circles, as a concept, because of its inherent untidiness, and because our progress made in understanding it can at times be painfully slow, complexity has become subject to some controversy and much skepticism. Yet rather than being daunted by any of it, Melanie Mitchell prefers to delight in the uncertainty and the vagueness that is complexity. And it is her own enthusiasm for the subject that, as much as anything, draws us along on the journey, indeed on the tour together with her. The first thing we learn is that instead of thinking of complexity as a single individuated concept, we are much better served by thinking of it more precisely in terms of complexities. That is, as actual systems of complexity that coexist as discrete entities and yet also in mutual interaction. Mitchell helps us conjure up imagery for this particular paradigm, which she underscores all the more by her evocative use of such subtle devices as referencing the Latin root for the very word complex, that being plectere, which means to weave, to entwine. The array of examples of complexity with which Melanie Mitchell presents us is truly staggering. Moreover, equally impressive and fascinating is her capacity to achieve a fruitful and provocative balance between the kinds of examples that we would naturally expect, insect colonies, the human brain, and the human immune system, and those we would not, seemingly unconnected economies, and the World Wide Web. Also remarkable is her ability to humanize the subject of complexity by supplying us with details on the lives of those who inhabited its worlds and grappled with its unruliness and its promise. My personal favorite, the Hungarian-born Johnny von Neumann, who, as Mitchell describes him, unlike Einstein and Darwin, was a child prodigy. He supposedly could divide 8-digit numbers in his head by the age of 6. At the same age, he also could converse with his father in ancient Greek. However, to its credit, what is probably the greatest achievement of Melanie Mitchell's book, Complexity, A Guided Tour, is the degree to which it illustrates the positive potential outcomes that might result from increasingly direct interfacings between various complex branches of the sciences and real-world socio-political concerns. In particular, Mitchell's discussion under prospects of computer modeling of the evolution of human cooperation employing the time-honored model of the prisoner's dilemma is really quite masterful and timely, just as are so many of the other gems included in this fine work. So in the end, I can only advise even my fellow non-scientists to follow my own lead and accept the challenge of being willingly disarmed and enlightened. As the author herself intones, quoting, "No background in math or science is needed to grasp what follows, though I will guide you gently and carefully through explorations in both." Ladies and gentlemen, how can anyone say no to an invitation like this? And so, with gratitude for her invitation to knowledge and her extraordinary accomplishment, the Society proudly confers the distinction of the 2010 Phi Beta Kappa Science Award upon Melanie Mitchell. Please join me in welcoming.
So I'm very, very happy to be here, and I'm absolutely thrilled to be honored by this prestigious award from the Phi Beta Kappa Society. Thank you very much. So Dawn already told you all about my book. But I'll try and say a little bit more. I'd like to tell you a little bit about why I think complexity science is important and relevant to everyone here. First, what is complexity? In scientific terms, complexity is the study of how systems composed of many interacting parts can produce behavior that is much more complex, if you will, richer and harder to understand than the individual behaviors of those parts and their interactions. Indeed, in the sciences of complexity, the whole is much more than the sum of the parts. Some examples of complex systems include the following. The brain, in which trillions of neurons and neural connections collectively produce the behaviors that we call intelligence, or cognition, or consciousness. A biological cell, in which myriad molecular components interact in complex chemical pathways, collectively enabling the cell to metabolize energy, maintain and repair itself, self-replicate, and communicate with other cells. The immune system, in which trillions of cells and molecules constantly interacting and signaling one another, collectively create an adaptive, and one could even say intelligent, defense and repair system that generally keeps us alive and in good health. Ant colonies, in which hundreds to millions of individual ants, each employing relatively simple behaviors, collectively produce what some have called a superorganism with its own highly sophisticated and adaptive behavior. Social networks, which due to technologies such as the World Wide Web, are becoming increasingly distributed geographically, and in which the network as a whole has its own complex dynamics that is separate from the individuals making up the network. Finally, economies and other large-scale human organizations, which, like social networks, take on a life of their own, with behavior that we now know more than ever is hard to analyze and predict. These are just a few examples of the kinds of systems studied in the sciences of complexity. None of these systems is very well understood by science at this point. However, many people have become excited about the sciences of complexity because of some of the tantalizing commonalities that have been discovered across these many diverse complex systems in nature and society. People are excited because the study of these systems truly requires a cross-disciplinary perspective in which traditional disciplinary boundaries in science are bridged or even broken down entirely. There is a sense that we are on the verge of something very new, a set of new approaches and ideas, ones that are not yet part of any existing scientific discipline, approaches that will have a big impact on the way science is done and will allow us, as never before, to understand complexity in nature in a more unified way. Such an understanding would affect all of our lives and help us in tackling the many problems we are facing, brought on by the increasingly complex world in which we now live. My book is about this emerging new science of complexity. In the book, I trace the intellectual history on which this new science has been built and survey some of the approaches the field is taking in disciplines ranging from physics to biology, from computer science to political science, from sociology back to physics again. I also examine the prospects for a unified theory of complex systems and what such a theory might mean. In the book, I try to give space to both proponents and critics of complex system science and to show some of the struggles inherent in defining central concepts such as self-organization, emergence, and even the term complexity itself. The book raises more questions than it gives answers, but this is what happens when you try to survey a science in the making. I want to end my remarks this evening with a few comments about what this award means to me. I have to say that winning this award is a huge event for me. This is my first book written for a non-scientific audience, and writing it turned out to be one of the most challenging projects I have ever taken on. At times, I doubted I would ever finish it. Probably common to many authors of books. I wrote the book because I wanted to communicate to readers how fascinating and important I think this field is. I also wanted to demonstrate that even though the ideas can be difficult and daunting, I believe that they can be understood in a significant way by anyone with interest and dedication, not just by professional scientists. Tonight, I want to voice my appreciation to the Phi Beta Kappa Society for their recognition of science writing in general, not just my book, and their recognition of communication between scientists and non-scientists, which is becoming so important as our world becomes ever more complex. In closing, there's a quotation from one of the reviews of my book that I wanted to share with you because it sums up exactly what I was trying to do in the book. This particular review appeared in a somewhat unlikely place for a science book. It appeared in a periodical called The Magazine of Yoga. It says, I quote, Mitchell writes about science the way Julia Child writes about deboning a raw chicken all by yourself. Can you get a review like that? And they go on. You may wonder if you can really do it, but then ambition gets the best of you and you throw caution to the wind. Good for you. At first, I found this analogy a bit jarring. However, after some thought, I realized it is perfect. This is exactly the role science writers should play. Like Julia Child did for cooking, science writers can, through their writings, give ordinary people the courage and confidence that they too can understand the hard stuff of science. And on the subject of courage, I have to say that being honored by this prestigious award from the Phi Beta Kappa Society has helped give me the courage to even think about writing a second popular audience book on science. Thank you very much.